Before we get into this week's video, I just wanted to remind you about the live stream I will be doing on October 19th at 1 p.m. Mountain Standard Time. Depending on the number of folks that are watching, it'll be between 30 minutes to an hour long. And Neo Hippo, that is the maker of the ET30 dual speaker, dual amplifier switcher that I did a review on. It has the nice big VU meters. It doesn't destroy your sound at all. It's a real nice unit. They're going to provide 2 of those, it turns out. And the only requirement if you win the item is that you follow them on Facebook. They do have a store on Amazon as well as a Facebook page, so keep that in mind. But I will tell you how to win that at the appropriate time in the live stream, but you just have another reason to tune in to the live stream. If you wanted to build your own preamplifier from a kit back in 1979, one of the options was this Hafler DH-101. The kit price was $200, and if you wanted to purchase it fully assembled, it was $300 or about $1,300 in 2024 money. It had a frequency response of +0 to -0.25 dB from 20 Hz to 20 kHz at not more than 0.001% THD over that band. It's a fairly basic preamplifier as far as that goes. We'll look at the features that it does have and do a little tour of the front, and then we'll go look around, see what's going on out back. And then I'll take the covers off and you can see what it looks like inside. Now, as far as I can tell, this was a kit-built one, and it looks like over the years it may have had some of the capacitors replaced. Now, once I got into testing it, I found out that it had a problem with the balance control. I would call it a dead spot. It has a few sweet spots, but big dead spots, and apparently that is a problem with the balance control. I was able to get it in the sweet spot in order to do the testing, and so most of the data was done with it in that position. Once I finished all the testing, I looked into what it would take to get another potentiometer for the balance controls, and they're just not available. Of course, they're pretty old. And I couldn't find any other, like, even used ones. So I came up with a simple solution for it, and you'll see that, and it worked, and I'll show you some before and after data, and maybe it will help some of you. So right now, we're going to get into the tour, and then there will be lots of data, of course, and my experience with using and listening with the DH-101. Here's a close-up view of the Hafler DH-101 preamplifier. Starting on the left, we have our volume control, and the outer ring is the balance control. You have bass and treble controls, and if you want to use those, you would press the tone switch here. Now, when one of these switches is being used, it turns white. Here, there's a white window effect that happens there. You have your power on LED indicator there. You have 2 Phono inputs, and those would be for moving magnet cartridges. Tuner input, in this case we have our auxiliary input, which is selected. We have a dub feature, you'll see that in just a little bit around back, kind of what that's about. Then we have our power button and a mono switch and our 2 tape monitor switches. And so going around back, you can see on the left we have 2 unswitched AC outlets, 2 switched AC outlets. We have our patch switch, would be for the dubbing. I'm guessing that is if you had an equalizer you wanted to run in to the signal processing portion, you would do it through this. You could always do it through the tape monitor, but I'm pretty sure that's what the function is here. Also, the outputs and inputs are separated, which is kind of nice. So you have your main preamplifier outputs here, and then you have each of the outputs for the tape monitors here, and each of the inputs for the tape monitors here, and then your auxiliary and tuner inputs, as well as your 2 phono inputs, and then you have a ground input over here for your turntable grounding. Here is what the DH-101 looks like once you remove the top cover. We have our main circuit board here. We have our power supply circuit board here, power supply transformer. We have some of the function switches here, and this little guy right here is an Allen wrench, which is used to remove the set screws for the bass, treble, and your volume balance control knobs. It looks like the capacitors may have been replaced. I don't think these are original here. I will mention in the data that there was a problem with the right channel's balance control. It just had a dead spot in it. And the two balance pots are right here. These are your volume pots, and you'll see what I did to repair it. And now, unfortunately, most of the data I took was with the balance tweaked to just the right spot that worked, but it did allow for more noise on the right channel. And I'll have a little bit of data that shows what it looked like after the repair was made. This is just another view, kind of seeing where all our inputs and outputs are right here, and our AC outlets are here, and you just see a little bit of the power supply here. This is what you will see once you remove the bottom cover of the DH-101. Power supply boards here. Here's some more switches, and our main boards here. Now, I mentioned there was a problem with the balance pots. So what I did is I removed the solder from around both balance pots. You can kind of see it a little bit here, and then it's also underneath here. And then what I did is I measured the pots. There was no value given in the schematic for the pots, but I measured them and figured out that they were about 30K from wiper to wiper. So what I did is I removed the solder around the balance pots, and then I wired in 15K ohm resistors from the center pot to each of the outer connections of the pot, I guess you would say. And so the center wiper got wired with a 15K ohm from the center wiper to one side of the pot, and then from the center wiper to the other side of the pot was another 15K ohm resistor. So I did that on both pots, and when I fired it up, the right channel had a bit more gain. So what I ended up doing was changing one of the resistors, and it would be this one right here. And rather than a 15K ohm resistor, it was an 18K ohm resistor, and that balanced things out very nicely. So that's kind of my little engineering fix to the problem. The frequency response didn't really change, but the channel balance got better, and the noise went down, and the THD went down on the right channel when I kind of did this manual repair. Now, you give up the balance control for better noise, plus if the balance control weren't in the right spot, it could really drop the output level of the right channel. So it is a very practical fix. And since the balance control or the volume balance control assembly isn't available anymore, this is really the best fix that I could come up with. Here's our standard THD SNR plot at 1 kilohertz with a 2-volt signal applied, or 6 dBV. I've adjusted the volume control to give me close to 1 dB of gain, and I've played with the balance control so that the two gains are about the same. Balance control is flaky on the right channel, and that's part of the reason why it's noisier. And I'll actually show what happens when you miss the sweet spot of the balance control. And everything gets all wacky when that happens. The THD is specified at better than 0.01%, which we have for the left channel. The right channel is not quite there. You can also see that the SNR for the right channel is 12 dB worse than the left channel. Now I could adjust the right channel just a little bit and get this to improve, and I will do that a bit later on, but for right now I'm going to keep it so that the gains are balanced. So right now we have a 1 kilohertz 2-volt RMS signal going into the Hafler. We're using the auxiliary input. I've adjusted the volume control for about as much gain as I could get, which is pretty close to 15 dB. Our distortion is still pretty good. It's less than, we'll say 0.03%. The right channel's SNR is not as good as the left channel, and you can kind of just see how much the noise is greater on the right channel, and that has to do with the balance control having some issues with it. But we're getting out, we'll call it close to 11 volts RMS coming out, and that's probably about the max we're going to get. I could go up just a tad more, and then this thing's going to get real ugly. So we'll say we could get about 11 volts RMS out of this preamp if we needed to, with a 6 dBV signal going in. Here is the DH-101's frequency response from 20 Hz to 20 kilohertz with a 2 volt RMS signal applied. You can see that it is pretty darn flat, maybe 0.2 of a dB down here at 20 kilohertz, and the specification is that it should be not more than 0.25 dB down, so it meets that requirement. Also, the channels are balanced within 0.1 of a dB, and that's after playing with the balance control, which has some issues, and I will show that a bit later on. I should mention that the tone control is in the bypass mode, so it's in the out position, so we are not going through the bass or treble controls. And also I'm using the auxiliary 1 input and measuring at the preamplifier output for all of these tests until we get to the phono stage. Here is the DH-101's crosstalk between the left and right channel. In this case, I'm just using the auxiliary input. And you can see that the worst case crosstalk is at 20 kilohertz of about 40 dB for the right to left crosstalk, and it's a bit better, 10 dB better at 20 kilohertz for the left to right crosstalk. And as it indicates up here, it's with a 2 volt signal applied to the input and the volume control set for 0 dB of gain. Here is the DH-101's THD versus frequency for a few different input signal levels from 20 Hz to 20 kilohertz. The 0 right here would be 0 dBV applied to the input signal, and minus 15 would be minus 15 dBV signal level applied to the input. The specification is that it should be better than 0.001% THD over that band, and really only a small amount is for, it looks like, the 0 dBV input signal level case. However, once we get above 30 Hertz, which would be right here, so once we get down to say 40 Hertz, which would be right here, our THD is better than about 0.06%. That's not too bad, but it is not as good as the specification. Here's the DH-101's multitone response, and it shows a distortion-free range if we ignore a few of these scragglers of between 13 to 14 bits. Here is our system noise plot. In this case, we have selected the auxiliary input, and those inputs are terminated into shorts, so you're just looking at the noise of the preamp. Predominantly, the noise is the power supply hum here at 60 Hertz. Now, there is a specification that with A weighting applied, it should be better than 90 dB down, the hum and noise, and with A weighting applied, 90 dB would be right here, and indeed we are meeting that requirement. So right now we're going to look at the isolation between two inputs. In this case, I have a 0 dBV signal going to the tuner input, and the tuner input is selected, and then I have shorts on the inputs to the auxiliary. Now, you can see that with a 0 dBV signal, both the left and right channels are at 0 dBV. What I'm going to do now is switch over so that the selected mode is the auxiliary input. The difference between 0 and what we see down here is how much channel-to-channel isolation. You obviously would want that to be as far down as you could go. You see that the 60 Hertz line here for the right channel is coming through at minus 40 dBV down, or 40 dB down. But once we get beyond that, for the most part, we're probably better than, I would say like 62 dB of isolation between the two inputs. There is not a specification for it, it's just a figure of merit kind of thing, and 60 dB would be pretty decent from what I have measured. Right now we're seeing what happens when we vary the bass and treble controls. There is no loudness switch on this, or high filter or low filter, so we'll just see how much the bass and treble controls affect things. And there is a specification that the bass control should be plus or minus 12 dB at 50 Hertz, which would be right here. So right here we're at, I would say about 15 dB, so it's a little off, not too bad. And right here we're right at 12 dB on the plus. The treble should be plus or minus 10 dB at 20 kilohertz, so we're pretty darn close to 10 dB there, but we're a bit more than that. We're more like, I would call that 16 dB of attenuation at the high end of the band. So for the most part, I would say that the tone controls are meeting their requirements. This plot shows the IMD performance with two tones going in, and we've got a 20 kilohertz tone and a 19 kilohertz tone at minus 3 dBV going in, and that would be these guys here. And what you're looking for are 1 kilohertz sum and differences between these two, and then there's going to be some that are summed up here at the really high end of the band, but you don't see those on this graph. But they're not part of the normal IMD equation that I use. There would be a big one here at 1 kilohertz that would be of interest, and it's big for the right channel, not so much for the left channel. And these guys right here are our power supply artifacts, and they don't factor into the IMD distortion. But if I were to drop this into the IMD calculator, it would be a very small IMD number. Right now we're looking at the Phono 1 input to the tape monitor 1 output, and this is with the standard minus 46 dBV input applied. We've got about 35 dB again, a little bit over that. We've got better than 0.0013% THD, and the SNRs are right around 60 dB. So I would say this has a very nice phono input stage from all of the ones that I've tested. So there is a specification for the phono stage that with a 10 millivolt 1 kilohertz signal applied, which is what we have, the hum and noise should be 86 dB down, and that is with the A weighting turned on, which I have done, and we're pretty close to that. We're maybe, that's say 82 dB down, so we're pretty close to 86, all things considered, under these conditions. Here we have the frequency response, and it has a specification that it should be better than plus or minus half a dB from 40 hertz to 15 kilohertz. So half a dB would be here, 40 hertz would be right here. So we're a bit beyond that. We're what, 7/10 of a dB, and then we're within half a dB the rest of the band. It's got some noise here on the left channel, but overall it pretty well meets the specification for frequency response of the phono stage. And once again, this is measured from the Phono 1 input to the tape 1 output. Here is our standard THD SNR plot at 1 kilohertz with a 2 volt RMS signal going to the auxiliary input, and the volume control was adjusted for about 0 dB of gain. Now this was after I modified the balance controls. Actually, I disconnected the balance controls from the circuit and used fixed resistors. They were 15 k ohm resistors with the exception of one of them, which worked out to be about 18 k in order to get the two channels balanced. Now it looks really, really good, and I'm going to go ahead and bring up a screen capture I did of the trace before. I'll just bring it over it right now, and one thing you could notice how the right channel, which is the one that had the bad spot in the balance potentiometer, you can see the noise level is increased, and I'm just going to go show that. So it looks much, much better, and we'll bring up the data here. So the big improvement is the THD. Now it really didn't do much with the left channel, but the right channel went from 0.031% to 0.0004%. So big improvement there. Also, I was able to do a little bit better gain matching, which it doesn't really show up here, but that was because I had the balance control in just the sweet spot, I guess. It's not a very big sweet spot. And you can also see that the SNR improved for the right channel here, and the THD plus noise also improved about 6 dB for the right channel. So overall, it works a lot better using the fixed resistor balance control method. Of course, you can adjust for your left and right channel differences, but for most people that really isn't a big factor. I'm not going to go and remeasure everything. I think I'm going to do one other measurement just to show the difference, but it did improve everything by going to that method because, like I said, the balance control just had a little sweet spot. Also, the frequency response plot, after I did the fixed resistor method for the balance control pot, it improved the channel balance between two channels. It was maybe 1/10 of a dB, and now it's about 0.05 dB across the band. It didn't really change the shape of the frequency response, just how close the two channels were, so that closeness is much better now. I thought I would look at the rise time for the DH-101 since there is a specification. Our input is basically a 1 kilohertz square wave in purple. That's that guy right there. He has a pretty quick rise time, 40 nanoseconds. And that's going to the auxiliary input, and we're measuring at the preamp output with the voltage set for about 0 dB of gain still. And that is our yellow trace again, and its rise time is 2.74 microseconds. The specification is the rise time should be better than 2 microseconds, so it is off on that requirement just a little bit. So right now we're going to look at the phase difference between the input and the output of the DH-101. I've got a 1 kilohertz sine wave going into the auxiliary input, and we're measuring at the preamplifier output. It's loaded into a 47 k ohm resistor, and we're measuring the voltage across that. And there really is no phase difference between the input and the output of the left channel is the one that I used, and that is at 1 kilohertz. Let's change frequencies. This is at 10 kilohertz. So at 10 kilohertz, we do have a little bit of change in phase. I'm not really sure how much that is, maybe 5 to 10 degrees, I'm guessing. Now, if I switch the frequency back to something lower at around 100 hertz, you can see that there really is no difference in phase between the input and output. And lastly, I'm looking at the difference in phase between the two outputs. So both outputs are loaded down by 47 k ohm resistors. We're looking at the difference in phase between the left and right channels at 1 kilohertz, and there really is not any change, or it's a little bit over 1 kilohertz, so there really is no change in phase there. And lastly, I moved it up to 10 kilohertz, and we still don't have any real change in phase between the left and right channels, which is a good thing. As the test data shows, the DH-101 came close to meeting its specs. Some places it met it, some places it didn't, and overall it showed that it's a competent preamp, I would say, as far as its measurements go. Now, one thing that I noticed when I hooked it up to my listening environment, which would be with the Bryson 2B LP amplifier, and then I use my little Surfans music player. And before I do any of that, I kind of just listen to the noise of this. You're hooking into an amplifier that has about, was it 28, 29 dB of gain, so any hum and noise is going to be obviously amplified by that power amp. And so when I terminated the auxiliary inputs and selected those, the gain was probably about halfway, probably at about, maybe minus 3 dB or somewhere position. It did have some hum and hiss at kind of a low level, but you could hear it, and it was mainly from the preamp. I hooked in my Carver C1 preamplifier under the same conditions, and it was much quieter. So there is a little bit of the hum and hiss there, and you could kind of see that with the 60 hertz noise hum bar in the data that you saw. Now, as far as, is that really a problem? Not really, because once you're playing music, at least the kind of music I do, which is not classical, so there's not like a lot of quiet periods in it, you don't really hear the hum. And even if it was classical, it probably wouldn't really hear it once you were playing at any decent normal listening level. So that was really the only little thing I noticed, although when I turned it on, sometimes you'd hear like a little thump, a little pop, very small. But other than that, I thought that it worked really well as far as the preamplifier. I thought the sound was, clean, and I didn't think it lacked anything. A loudness control, it lacks, but it does have bass and treble controls, so you can adjust those to make up for loudness control. And overall, I just thought it worked well as far as a basic preamp. I mean, if you were looking for putting together a vintage system, or you wanted to stick with something from Hafler that was a real reasonable price, it does a basic job. It has a tuner input, which probably isn't as important these days, but you could have 2 auxiliary inputs then if you were to get one of these things. And I thought it sounded just fine. It worked rather well as a preamp, so that's kind of what you want. So that's kind of my take on it. Now, you saw how I did the balance control fix, which is basically using fixed resistors. There was 3 15K ohm resistors and then 1 18K ohm resistor. I started with 4 15K ohm resistors, and the balance on one channel was off, and I played around with sticking different resistors in and found that an 18K ohm resistor on the one leg provided me with the pretty equal balance. So that's what I went with. Most people don't really use the balance control much. The owner was very happy with the solution that I came up with, and it seems to work just fine. So that's kind of it in a nutshell on the DH-101. If you liked the video, give me a thumbs up, and if you have not subscribed to the channel, I would really appreciate if you did. So until next time, have a great day or night.